Hi guys, friendly neighborhood math teacher here. Well, not exactly here. I have gone home because I'm really not feeling very well and I don't want to get you guys all sick before Christmas. But I also don't want you to fall behind. So, we get to do our lesson this way today. I know we've done this before and it's worked marginally well, so we'll go try it again. So please be good for our sub. Mrs. Harris is great, so tell her hi and thank you, and let's get ready to go work today. Okay, so first thing is, would you please take a few minutes and it says jump starting your brain, no calculator. Go see how many of these you can do without checking your calculator. I promise every one of these is a no calculator kind of question. I'll give you a few minutes. I'll get out of the way. You can pause the video, see what you can do, and kind of call out answers and talk about answers as a class, and then unpause and come back and see if you are all right, okay? So I'll step out of the way and go pause the video. Ready? All right, let's see how many of these you remember. One of the things that we did not talk about very much last time, I'm sorry we ran out of time a little bit, was this natural log, ln. And natural log means log base e. So anytime you see natural log, you can rewrite it or even think about it as log base e, and sometimes that's going to help. So let's go look at these first few. Ready? So the very first one says an e. It is a base of e. And if I change natural log to log base e of 32, looks like a horrendous problem, right? I would agree. But you remember that there is a trick? Promise there's a trick. If you have a base of e, and then the exponent says log base e, if you have log base e and an actual base of e, they get to cancel out. And what's the only thing that you're left with? 32. So 32 is it. That's all. Question number 1 is 32. I hope you got that one right. Let's look at number 2. Same kind of idea. It just doesn't say natural log. It says log base 8. So you have log base 8, and it has a base of 8. Well, log base 8 and base 8 get to cancel. So your answer is just 3x. Done. Question number 3 over here. Written a little bit differently, x in a slightly different place here. This one I'm going to rewrite without the word logarithm. You remember what logarithm stands for, right? Logarithm just means an exponent. So I'm going to go rewrite this without the word logarithm, just as an exponential type equation. So what's my base number? 25. Are we taking 25 to the x power or 25 to the 3/2 power? Remember, if it says the logarithm is 3/2, that means the exponent is 3/2. So we're going to take 25 to the 3/2 power. And when all is said and done, we're finding x. Now we just have to remember how to take 25 to the 3/2 power. I know some of you guys struggled with that on the last quiz. Probably time to look over those in your notes. We do need to know how to do these fraction powers. So we're going to take 25 and split that 3/2 exponent apart into 1/2 and then a power of 3. So what is 25 to the 1/2 power? 1/2 power means square root, so that's a 5. So we're going to take 5 to the 3rd power. 5 times 5 times 5? 125. So x is 125. Kind of ran into the other one, but that's okay. All right, let's see. Let's switch colors so you can tell the difference here. All right, problem number 4. What does natural log mean? Log base e. So you have log base e and then an e to the 5th. So really what we're asking is e to what power gives you e to the 5th? Or a log base e and a base of e will cancel. And we just get 5. All right, what about the next one, number 5? It's got the word log in it, it has an equal sign and everything, so I think we can make it an equation and just take out the word log. So base of 16 to the x power makes 4. 16 to the what power is 4? I know in your head some of you are thinking, well, I'm dividing it by 4. True, but that's not exactly multiplying and dividing. We're doing square roots, cube roots, quarter roots, things like that. What do you think? what can you do to 16 to get a 4? You square root it. And how do you write a square root? Half power. All right, last two. Log base 10. How did I know it was base 10? Because it's missing, and that's the common logarithm. It's so common we can leave it out. So 10 to some power gives me 10,000. 10 to some power gives me 10,000. All I really have to do is count the zeros. How many zeros? So x is 4. All right, last one. Looks like I can probably rewrite this as an equation without the word log. I have a base of 2, so I'm going to write 2 to the 5th power, and it will equal 3x plus 2. It's literally just an equation to solve as soon as I figure out what 2 to the 5th power is. And if you're like me, you have to count on your fingers. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 makes 32. So I have 32 is 3x plus 2. Minus 2, I'm thinking x is 10. I hope that you have all of those, and if you had any questions or problems on those, that you can kind of look at those and go, oh yeah, I know what's going on. All right, so we're going to go work on logarithms, exponents a little bit more. Go figure, it's our exponential kind of chapter, so surprise, surprise, we're going to be working on exponents and logarithms. Let's go see what we're going to go do first. Okay, before we jump into all of these logarithms and exponents, I thought maybe we'd go step backwards because it looks like we kind of need it. I thought maybe this would be a good thing to do. So how about this? There are 3 questions on here, and they all deal with the same 2 points. So let's look at each one of these and let's decide what we need to do and what's different about these problems. So the first question says, because I know sometimes it's hard to read on here, find the linear equation. Notice it says linear, we're making a line, that contains the points 0, 2, and 2, 8. So we are looking for a straight line. And you guys have worked on lines since pre-algebra, but still I know some of you guys have the hardest time making the equation of a line. You have done this for years, guys. It's probably time to learn how to make the equation of a line. All right, so there's a couple of different ways you can get the equation of a line. You can do y equals mx plus b, or you can do our lovely point-slope formula. Personally, I would do point-slope formula because I have some points, but I know most of you guys are going to do y equals mx plus b, so I'm going to go work there. All right, so if we just even sketching it, right? I have a point at 0, 2, and I have a point at 2, 8, 3, 4, 5, 6, 7, 8. We are looking for the straight line that goes through both those points. How do I know I'm looking for a straight line? Because it says linear. Literally, that's it. It just says linear, so I'm looking for a straight line. Okay, anytime we get the equation of a line, we need a slope. Let's go find slope. You know how to find slope, right? Slope is y2 minus y1 over x2 minus x1. We will subtract our y's, we will subtract our x's. Of all the numbers on here, what are the y values? My y values are 8 and 2, so I'm going to subtract them. 8 minus 2. And notice that I went 8 minus 2. Not 8 minus this 2, 8 minus this 2, the y's. Now I have to subtract my x's in the same pattern. If I went second point, first point, I got to go second point, first point. And what are the x's? 2 and 0. 2 minus 0. 8 minus 2 is 6. 2 minus 0 is 2. I'm getting a slope of 3. Got a slope of 3. All right. I suppose I could go through y equals mx plus b and figure out what b is, but I actually know what b is. B is your y-intercept. Do you know your y-intercept? It's 2 over 0 up 2. So I've got the equation of this line. Y equals 3x plus 2. That's if you have these 2 points and you are putting a line through them. So what happens in the second one? Not a line anymore. Second one says, find the quadratic equation. Oh no, what's a quadratic equation? You remember what a quadratic is? That's a parabola, something that has an x squared in it. All right, so if we have an x squared, well, I've got to write a parabola equation. Now look at the information that you are given. It says it's got these points, the same points, 0, 2, and 2, 8. And oh, by the way, 0, 2 is a vertex point. So this time, when I have 0, 2, it's a vertex, and if I'm not even counting here, I've got a parabola like this. Not a line, a parabola, no slope. Parabolas don't have the same slope all the time. They change slope, that's what makes them a curve. So we need a parabola, and we have the vertex. Maybe it would be good if we use vertex form. So think for a second, go flip back in your notes, go back to last chapter. Do you remember vertex form of a parabola? Go back and look, I know, I'll hang on. Y equals, starts with an A times x minus h quantity squared plus k. H and k are our vertex. H and k, x and y
At this
are
time,
the point.
please allow the students from
I'll hang on for a
FFA
second.
to enter your class. They're just getting done with their fruit. Again, please allow the students back into class.
Okay, let's go put some letters in or some numbers in. Well, h and k are my vertex, so I'm going to go put in 0 for h and 2 for k. So I have y is a times x minus 0 quantity squared plus 2. This is actually really close to being finished getting my vertex form of a parabola. And you don't have to write x minus 0. You can now just write x squared. It's okay, but I'm leaving it there so you see where the 0 is. I just have to find an a value. I'm pretty sure a is positive because my parabola is going up, but we have to find what that a value is. Let's put our other x and y in there, fill in all the other numbers, then we can figure out what a is. So, y is 8, a I'm not sure about, x is 2. 2 minus 0 squared plus 2. Okay, we have talked about this quite a few times, but still, again, we've got some people making the same mistake. Remember, we take 2 minus 0, which you know is 2, and 2 squared. Now, do you take 2 squared plus 4? Do you do 4 plus 2? Sorry, thinking ahead. Do I take 4 plus 2? No. Remember, this 4 is times by a. So you have 8 equals 4a plus 2. Not 4 plus 2, 4a plus 2. Now go solve. So if I minus 2 from each side, I've got 6 equals 4a. So a is 6/4 or 3/2. So if I go write the equation of my parabola, y equals 3/2 x minus 0 quantity squared, or you're fine just writing x squared, plus 2. We haven't used that formula for a little while, have we? All right, last one here. Find the exponential equation that contains these points. All right, it's kind of like having the list, just a list of 2, like having the little chart. Let's go write an exponential equation. Y equals a times b to the x power. All right, a is always our initial value, or our y-intercept. And what is our y-intercept? 2. So let's see, if it's exponential and we're here, that means we're doing this. Okay, so exponential equation, right? We got our 2. I am fairly certain that my graph is growth. I'm pretty sure my b is more than 1, but I don't know what it is. So let's go put some numbers in. Do we have another number for x and y? Why, yes we do. So we get 2 times b squared, there's x, and y is 8. So I'm going to divide by 2 first. And so I'm going to square root. So b is 2. I know it's growth, it's got to be more than 1. So I'm counting b as 2, not the negative 2. So y is 2 times 2 to the x power. Look at that. We have taken 2 points, we have found a line through them, we have found a parabola through them, and we have found an exponential graph through them. It's a lot of different things that we've done, but trying to put a few different things together and just remind you. Hopefully that was fine, right? I know maybe you've kind of forgot about vertex form of the graph. That was a while ago, but I'm hoping that this exponential one went pretty well. All right, let's keep going with exponentials today. It's actually not that bad today, promise. All right, so I know we've said this like 4,000 times and you're rolling your eyes at me about now. Don't roll your eyes, that's a good thing if you know what I'm gonna say. Logarithm is just another word for what? Of course, it's another word for exponent. Now, see if this makes sense. If a logarithm is an exponent, then they follow exponent rules. Remember, exponents kind of have their own rules. Logarithms follow those exponent rules. So kind of maybe need to talk about those exponent rules, and I'll show you how they work with logarithms. It'll be okay. So, reminding you about some exponent rules. If you have x to the 5th and you multiply by x to the 7th, x to the 5th times x to the 7th. If I write it all the way out, I'll do it on this first one. We have x to the 5th, that's x times x times x times x times x, right? And I'm multiplying it by x to the 7th, 7 more. 1, 2, 3, 4, 5, 6, 7. We get x to the what? We get x to the 12th. So if you're multiplying, it's a multiplying problem, but what do your exponents do? They add. So keep that in mind. Let's look at the next one. So if you had x to the 7th and you divided by x to the 4th, 1, 2, 3, 4, 5, 6, 7, and I divide by x to the 4th, well, a bunch of them are going to cross out. 1, 2, 3, 4 sets will cross out. I am left with x to the 3rd. So even though it is a division problem, what do you do to your exponents? You subtract. Okay. Please tell me that that sounds familiar. So if you remember your exponent rules, those are the same things that go along with logarithms. Those are logarithm rules too. Look, we're like almost halfway done. Okay, it's going to be a little bit of writing today. You need these examples. Please put these examples in your notes. Get ready to write. It's not like tons and tons and tons of notes, but it's a lot of little small examples. So here we go. The first thing that you need to know, there's something called the product rule, and we are involving logarithms. Product rule. Product rule says you're multiplying, right? But you're multiplying with exponents. Okay, so it says I have log base 8 of 15. I know that's some number. I'm not even worried about what it is. And it says log base 8 of 2. Okay. First thing to notice is that they are both log base 8. They have to be the same base in order for me to really add them together. It's like having like terms. If it would say log base 8 of something and then it would be like log base 14 of something, I wouldn't be able to do this. The bases do have to match. So that's always something to look at, just in case Math Excel tries to trick you later. Okay, so one more time. I have log base 8 of 15 and I have log base 8 of 2. Well, I can actually kind of combine those ideas and put it into one logarithm. I'm adding logarithms, I actually get a logarithm answer. So, if it says logarithm base 8 and logarithm base 8, my answer is a logarithm base 8. Don't just go for the number, you have to have logarithm base 8. So, now I'm going to go put those final numbers together. It says 15 and it says 2, right? But logarithms deal with exponents, so we actually have to do exponent kinds of things. What happens when you add your exponents? That's a multiplying problem, right? If you are adding exponents, you have a multiplying problem. So we're going to take 15 and 2, and we are going to multiply them together. So this is the same thing as log base 8 of 30. I know it looks like an addition problem, and it's probably like, oh, I want to add 15 and 2. But remember, logarithms are exponents. We are adding our exponents. That means we just have a multiplying problem. All you do is take the 15 and the 2 and you multiply them together. Now, the answer isn't 30, but it's log base 8 of 30. That's how you get that number. Let's try it a few more times. So, it says log base 7 of 2 plus log base 7 of 13. They both have log base 7, that's what we want. It's kind of like having like terms. So I know that my answer will say log base 7. I just have to figure out what that final number is. And again, if you are adding exponents, that means you have a multiplying problem. So we are going to multiply 2 and 13 and get 26. Not so hard? It's one of those weird things, it's hard to remember to do it, but actually doing it isn't that bad. Let's try one more time. So log base 4 of x, now you have a variable, it's okay, and log base 4 of 2y. So they're both log base 4s, so you will have log base 4 in your answer. You're going to multiply the x and the 2y, and it's okay to write x, 2y, or you can shuffle them in any order. I'll probably call it 2xy. But if you write 2yx, it's all the same thing, right? Okay, so this right here is what we call condensing. You are taking things that are added or subtracted and you have condensed it down into one logarithm. That word's going to come up later, but I'm throwing it now. We are condensing. Now we're going to switch gears a little bit on these three and we are going to expand them. It's kind of in one logarithm, we're going to make it several logarithms. Sometimes it's good to break it apart, sometimes it's good to put it back together, it just depends on the problem. So let's try these three. This says log base 6 and it is of x times y. Log base 6 of xy. Well, I notice that they are multiplied. If you're multiplying, that means you are really adding exponents together. So when I break it apart, I have log base 6 of x plus log base 6 of y. Because remember, when you are adding things with exponents, you are adding your exponents, it's a multiplying problem. So I just expanded it out. I went from multiplying, changing it to a plus. Let's do the second one, right? Log base 5, and it says 3a times b. 3a times b. Okay, so I know it's going to say log base 5 of 3a plus log base 5 of b. So far so good? There's actually one more thing I can do. Do you see what it is? There's something you can do with this 3a. That 3a is multiplied together. You can break that apart. Please do. So I'm going to break that one apart. Log base 5 of 3 plus log base 5 of a. And I still have plus log base 5 of b. So when they're all added, that means the 3 and the a and the b all get multiplied together, and that's really what I have is 3ab. Okay, so why don't you take just a second, see what you can do with this last one. It's not that bad. It just says log of 4m. So you have two things multiplied, a 4 and an m. Go expand it out into two separates. Log of 4m. Got it? Did you notice that there was no base number? You know that that base number is 10. So if you want to put the 10 in, you can, or you can leave it out. So I have log base 10 of 4 plus log base 10 of m. And I know, because about now people always ask, why in the world do we ever need to do this? Well, you just got to trust me for a few until we get to the problems. Some problems, these things get really complicated, and if we break it apart, sometimes we can take separate ones and actually figure out what those logarithms are, and we can simplify the problem. Sometimes if you have ones that there's a whole bunch to, it's good to put it all together and you can simplify it that way. It's just one of those things, and just kind of figuring puzzle pieces and how all these things fit together, honestly. All right. See, look, we're halfway done. Ooh, that's dark. Okay, let's try there. Okay, so we just did product rule. When you are multiplying, it really ends up being adding. Now we have quotient rule. I have a feeling you know what's going to happen here, right? So you have log in the beginning, log. It doesn't have a base number, so that means log base 10 of 4/5. 4 is being divided by 5. That's a division problem. And remember in the very beginning when we had, what was it, x to the 7th divided by x to the 4, how you subtract the powers? Well, we're about to subtract. We're not subtracting 4 and 5, but we're subtracting logarithms. Okay, let's go do. So if it says logarithm of 4/5, I know that's log base 10 of 4 minus log base 10 of 5. This one we can actually check on our calculator. So pause me if you need to, grab your calculators. Okay, go pause, and then unpause, and we'll talk about how to do this one together. Ready? Pause. Oops, there's one. Okay, so I've got my handy dandy calculator, and I'd like to show you that this stuff really does work. I'm not lying to you here. So let's just type in log of 4/5. So I'm typing in log of 4 divided by 5, and I'm ending my parentheses, log of 4/5. I have a negative number, give or take negative 0.0969 and a little more. All right, now try it as two separates. Type in log of 4 minus log of 5. Log of 4, I'm ending the parentheses there though, right? Log of just 4 minus log of 5, and I end the parentheses. Do you get the same number? See? I told you that it really works. I'm not lying to you, I swear. Okay, let's go try a few more. We don't have to check them all on the calculator, but I just want you to see it really, really does work. Okay, log base 3 of x over y, right? So I have log base 3 of x minus log base 3 of y. Got it. All right. Let me show you a common mistake, just in case. I don't want to like put mistakes in your head, but you can tell me what's going on here. This is what I see a lot when people are doing these. So it says log base 2 of a divided by 8. Log base 2 of a over 8. What tends to happen is this. Log base 2 of a minus 8. Is that okay? That 8 has to be part of a logarithm. If you're expanding it, it is part of a logarithm problem. It's not just the number 8. So the log base 2 of a is fine, but you're minusing log base 2 of 8. And actually, you know what that is. That's 2 to some power makes 8. That's actually the number 3. So you're not really minusing an 8, you're minusing a 3. And that's a difference if you put the log in or take the log out. All right. So, kind of switching gears, same idea, just coming at it from the other side. What if you have this one that says log base 4? So log base 4 of 18 minus log base 4 of 3. I know it's going to say log base 4, that's the other thing. Make sure you have log base 4 in your answer. And we have an 18 minus 3, we're not actually minusing. We have to change the minus into a division problem. 18 divided by 3. We can do better than that. What is 18 divided by 3? So I have log base 4 of 6. Done. Okay. Log base 2 of x minus log base 2 of 8. Log base 2 of x over 8. Done. All right, let's look at the very last one. Log of 32 minus log of 4. Base is missing, so you know it's base 10. So if it's minus, you know you're really not minusing. It's a division problem. And I've got to do 32 divided by 4, so that means my answer is 8. Is my answer actually 8? 8 is part of it, but remember, if you've got log on there, then you actually have a log in your answer. So it says log of 32 divided by 4, or log of 8. And there's a difference in that answer. Just kind of think, you aren't really like solving these, you're just simplifying them. So the word logarithm doesn't go away. I wish it would, but it doesn't right now. Okay, hopefully not too bad. Let's see how it goes. Okay, now we are on the downhill slide, promise. There's just a tiny little bit left to go. All right, it says to put these two ideas together, so let's do one of them together, and then I'm going to have you guys pause this, and you can talk with each other and see how it goes. So let's look at number 1 together. It says log base 5 of 3x plus log base 5 of 2. Log base 5 of 3x plus log base 5 of 2. All right. Well, I'm pretty sure my answer's got to have log base 5 in the answer. And if it's adding, remember when you add exponents, that's really a multiplying problem. So I must multiply the 3x and the 2. And what's 3x times 2? 6x. You do have log base 5 of 6x, not just 6x, right? Good. Okay, so I'll get out of the way. You guys pause, figure them out, talk with your neighbor. When you guys are ready, go on pause, check answers with me. Okay, let's go see how we did. I'm still on these condensing ones. I know it says number 3, but I'm going to go ahead and condense down. Log base 7 of 5x minus log base 7 of 2y. So log base 7 of 5x times 2y. So that's log base 7 of 10xy. Done. Okay, expanding says make it bigger, make it longer. If it has log base 8, I think I'm going to have it in there more than one time now. So log base 8, and it says x minus 2. Now, there was a little bit of a trick here on this one. Did you catch it? This x minus 2 is in it's in a quantity. It's not log base 8 of x and then a log base 8 of 2. It's a little bit more of a trick one. It's all together. We haven't really talked about what happens when we're minusing there. So you know what? Don't even worry about that one. I know you probably had some questions on it, but don't even worry. If you're really wondering on that one, you have log base 8 of x minus 2. You've got it in your quantity, and it's being times by a 1, right? That's okay. And then that means you are adding. So you have log base 8 of x minus 2 plus log base 8 of 1. I know it was a bit of a trick, and I'm sorry. Okay, the other one's not going to be so bad. Let's try this one. Log base 3, not a trick, of 9 over 2a. Okay, kind of a trick. Do you notice that there's a division and a multiplication in here? There's a division, and this thing is being multiplied. So let's start with the division first. Log base 3 of 9 minus log base 3 of 2a. But this 2a can be expanded a little more because it's being multiplied. So I've got log base 3 of 9 minus log base 3 of 2 plus log base 3 of a. And now what I would suggest, because we need order of operations, these two are multiplied, these two are being added, I would put a parentheses around those two. So I know that it's 9 divided by 2a. All right, so I gave you a trick, I'm sorry. Okay, only one more real idea here. Maybe try to get something that you can see a little bit better, sorry. It's called the power rule, and this is what happens when you already have an exponent, which is kind of weird to think that you have an exponent already in an exponent, but it happens. And the lucky thing is, this is really not so bad. So this would be a good one to write down and to put into your notes some examples. It says log of 2 to the third power. Now I know that 2 to the third power is 8, but we'll check it in just a minute and we'll kind of double check and make sure that these answers really are working. It says log base 10, and you have 2 to the third power. Well, if you want to get rid of this power, this 3 is going to come down and jump right in front. It kind of falls down in the front of this logarithm. So this can be 3 times the logarithm of 2. Okay, let's check that one on your calculator just to see that it works. Okay, so grab your calculator. I've got mine right here. It says log of 2 to the third power. So you can type in log of 2 to the third power, or you can type in log of 8, because 2 to the third power is 8. Either way you go. It's a big long decimal. Mine is starting with 0.903. I hope yours is too. Now go try this other one. Type in 3 times log of 2. 3 times log of 2. Same thing? It is. All right. So when you have a power, it actually comes down and becomes a multiplying. Do you remember about when you raise a power to a power, that's when you multiply? If you had x to the third to the fourth, that's x to the 12th. So a power to a power, you multiply. This is your power to a power. We have to multiply. Okay, so logarithm of 4 to the 5th power, whatever 4 to the 5th power is, can be written as, if I bring down the 5 times the log of 4. And that's really all we need to do. It's really okay. That one we could probably solve, but I'm not worried about it. So what happens in this next one? It says log base 3 of xy quantity squared. I'm going to change that just a little bit first. What is being squared in this problem? Well, all of it is. So this is log base 3 of x squared and y squared. So now when I expand it a little bit, I actually have two things going on. I have a multiplying problem and I have exponents. So kind of one at a time. If I just look at log base 3 of x squared, that 2 is going to come to the front. So 2 log base 3 of x. And remember what happens when we multiply? It's really an addition kind of thing. We're adding exponents. So plus 2 log base 3 of y. How did she do that again? Remember, the 2 comes to the front here, 2 log base 3 of x. And when you have something multiplied, I'm expanding it by putting the plus sign in. And then this 2 comes in front of my y term, 2 log base 3 of y. Let's try it one more time. So log base 6 of 5y all to the x power. So I'm going to kind of just distribute that x power first. Log base 6 of 5 to the x and y to the x. So we really have two things going on here. We have a power rule and we have that product rule. So we're going to have to do kind of two things at the same time. I am working on just log base 6 of 5 to the x first. I'm bringing my x out front. X times the log base 6 of 5. Now since it's multiplying, I expand that by putting a plus, and now I can deal with y to the x power. X log base 6 of y. So there's your power rule. That's probably the hardest one. And we're almost done. Okay, so I'm going to give you guys a couple of minutes, same kind of deal. I'm going to step out. I would love for you to pause the video, take a few minutes. You have 5 of these, and every one of these is an expanding one. So expand them out, that means make them a little bit longer. You'll probably be writing the word logarithm a couple of different times, 2 or 3 or 4 times. So you pause and then we'll check them. All right, so getting ready to check these. I hope that they were okay. Log of x to the 3rd power. That has a power, it's a power rule. So that 3 just comes to the front. 3 log of x. Done. Let's see, what about the other one at the top that has log base 6 of ab to the 4th? Now be careful on that one. Does the 4th power go with the a and the b? It's not quantity ab to the 4th power. That 4th power is only with the b. So that 4 is only going to come in front of the b term. So I guess if I do it in 2 steps, I have log base 6 of a plus log base 6 of b to the 4th. I split apart that addition, that multiplying by addition. Now this 4 comes in front of the b one only. Log base 6 of a plus 4 times log base 6 of b. How'd you do on that one? Okay? Hey, what about this one in the middle? Now, this one says natural log. I promise it works exactly the same way, because remember, natural log just means log base e. We've written log base 6, we've written log base 10. This just happens to be log base e, so it's all the same thing. You can just keep writing natural log. Let's see, I have natural log of n to the 3rd, and it's over an m squared. Well, the first thing I'm going to do is go get rid of that division, and that means I'm going to make a minus sign. So natural log of n to the 3rd minus natural log of m squared. I just broke apart the division by using minus. Now I'll use my power rule. Bring down that 3. 3 natural log n minus 2 natural log m. If you really want to write log base e, it's okay, but I think writing natural log is probably a little bit better. They are equivalent. I guess I'm just worried about Math Excel not accepting log base e when log base e is natural log. Okay, what about this one? I have a square root. Do you remember a square root, what power that is? Sorry, the battery quit, had to go change that. Anyway, we've got log of m over n all to the half power. That means every one of these things has a half power. So I have log of m to the half power, and it's over n to the half power. So we've got 2 things going on. We're going to have to take care of that power and that division sign. So maybe we can do it all at once? Let's see. M to the half power, 1/2 log of m, and the division sign is minus 1/2 log of n. Did you do okay? Okay, one last one here. I know it says natural log, but don't freak out. You do have a multiplying problem here, so that 3x is actually going to get expanded. We have natural log of 3 plus natural log of x. Since it's a quantity, I'm going to go ahead and put it in a quantity in some parentheses, just in case. And then the division sign is minus, and now you have a power. 4 natural log of y. Anytime you have kind of pluses and minuses and you have quantities, I would recommend putting your parentheses in there. All right, almost done, promise. Those were expanding ones. Now we'll do one more time. Let's go condense. You ready to go condense? These are ones that are out a little bit further. We're going to put them all down into one single logarithm. So make sure you have the word logarithm of base whatever or natural log. Okay? So I'm going to step out. You guys pause, take a few minutes, talk with your neighbors, see what you can figure out, and then unpause and we'll see if we can get them all right. All right, let's go see what we can do here. I noticed that they all have log base 2, so that's good. My answer definitely has to have log base 2. I have a 36, and I'm minusing, which means divided by, and this says 3 squared. And I have a feeling we can make this look a whole lot better. So log base 2 of 36 over 3 squared. Well, 3 squared is 9, and 36 divided by 9 is 4. So you have log base 2 of 4. And you know you can actually get that answer? This says 2 to some power makes 4. 2 to what power is 4? 2 squared is 4. So that answer is really just 2. I know if you were just condensing all down into logs, it'd be here. But I want to show you, you actually can get that all down to one single number. Okay, let's go try the next one. The purple one I know does not have parentheses on this one, so if it does not have parentheses, then we have to do order of operations. So this says log of, this says 8 times 5, and I'm dividing by 4. Now remember order of operations? Order of operations says when you have multiplying and dividing, you go left to right, whatever comes first. So I'm doing log of 8 times 5, which is 40, divided by 4. So that's log of 10. And that's also one that we can turn into a single number. 10 to what power is 10? First power. All right. Some of these we can have single numbers. I know you may not have done that. That's okay. What about this next one? I see log base 5, so make sure you have log base 5 in your answer. I see an x times a y divided by an 8. And again, there's no parentheses on here. There really should be. I highly recommend you to have them on there. But when in doubt, they always go left to right. So it goes x times y divided by 8. So that means if you are taking x times y first and then dividing by 8, you have log base 5 of xy over 8. Really and truly, to make it easier, we probably should have that in a parentheses, just in case. All right, if you're doing it, put a parentheses in. Okay, almost done. What about this green one? Natural log of x to the 5th minus 2 times the natural log of xy. Now really that xy should have been expanded. I was just trying to give you a break. So natural log, it says x to the 5th, and we are dividing by xy all squared. That can look better, you know that, right? So what if you squared out the x and the y? That's an x to the 5th, and you have an x squared and a y squared. These x's can simplify. So you have natural log of x cubed over y squared. How did she get the x cubed? You have x to the 5th and an x squared. 5 at the top and 2 at the bottom. 2 are going to cancel out. All right, last one. Natural log of x squared minus 3 all to the half power. Or you can write square root, it's completely fine. And we'll be dividing by x. Now, can I simplify these x's? I cannot, because this x is being taken to a power. And I can't just say that x squared is being square rooted because it's a quantity. So I could also write it as natural log of square root of x squared minus 3 all over x. I can't really touch anything that's in a quantity or in a square root. So that's as far as I can go. That's it. All right. Just kind of notice that you have 2 assignments. Neither one are super very long, just so you recognize. You have a Math Excel assignment, so you can get working on that. You also have a worksheet. Let me tell you about your worksheet. Okay. Your worksheet is this pink worksheet, so if someone from class, or Mrs. Harris, if you would hand out the pink worksheet. This is kind of a review of things that we have done so far. So there's this expanding and condensing stuff. There's also slightly older things from last week, not too far, about writing exponential forms, like predicting the population using an exponential function, things like that. It's one side, it's not that much. You'll probably need your calculator for some of it. It's got some big numbers on there. So you have Math Excel, make sure you get that done. Please make sure you get your pink sheet done. That will really help because you are having a short quiz next time. this will help you get ready for your short quiz. So please don't walk into class and say, can we review for our quiz? This is kind of your review for your quiz. I'm making it homework because I really want you to do it. All right, so see what you can do on your Math Excel. If it's not open just yet, see what you can do on your worksheet. Help each other out a little bit. Talk with each other. Be good for your sub. Hopefully I'll see you next time, okay? Thanks, guys.